All right, so the problem that we see, what happens if I want to create a new class for unbounded? And we know that bounded we can use array, right? Unbounded we can use linked list. Unbounded stack. And of course we have to implement what? I stack. But we don't want to have isFull here because unbounded means there's no isFull. Why don't we just remove isFull from here then? Then logical is not good. Then we can just do another interface then. And make it as I unbounded stack, which is extends from I stack. Actually, I should make it I bounded stack, right? I bounded stack. Refactor. I bounded stack. And then add this. Because you can extend the interface, right? Then this guy should implement what? I bounded stack instead, right? Okay, let's just do the same. Alt enter, implement all the methods that is required, right? Oh, I have to put E on the I. Yeah. So this is just some thing that we have to do when we do the generics. Now for unbounded stack, we can just do I stack. And do Alt enter. When there's an error, just click your mouse over, Alt enter, and add unimplemented methods, right? So okay, now let's look at our UML diagram a little bit. Then we understand what we have so far in a picture. So UML diagram is going to be a useful case now. So we're going to drag our utils, right? We have iStack. Let me look at this again. Right click on the package and diagrams, show diagram. It should show. So I have interface, right? iStack, and iBounded extends iStack, and classes implement iBound, right? The class is bounded stack, and bounded stack just implement iStack. Or technically I can just name stack and know that this is unbounded, right? For bounded, it's just name bounded. Okay, so just refactor again. And we know when we say stack, this is unbounded. Okay. All right. So this is what we have so far. So this is logical level. And when we get to class, this is implementation level now. So let me show you how do we implement stack. For bounded first using array. So should we just declare a data field which is an array, right? Now this is bounded. Of course, you have the size, right? So we're going to create a constructor first. Whenever you add the user level for abstract data type user level, right? User has to do the new operator for bounded stack. They have to provide something through the constructor. We need a constructor. So if the default constructor is being called, then we just going to set the constant as a cap. So final int size, let's make it maybe 10 or 100, and then we're gonna have to declare an array, which is the element itself. So an element is going to be E, right? Because it's generic type. So I'm going to be an array of element, right? Which is something like that, right? You can put E like that in front, right? So that's the attributes. Now we might want to do private, okay? And this is also private, right? Because these are the data fields for encapsulation. Now about the stack, pretty much just going to do E equals to new. We're going to create an object with the 100, right? So object, right, of the size, right? That is the default size. And this whole thing has to cast back to E type, right? Has to cast this back. How do we cast? So this is the element, right? And then we have to do E. We have to cast the whole thing. This is new object with a size. And we have to cast this whole thing, right? But this is an array of E. Then we have to cast into array type. Like that, right? Because it's an array. Could also create another constructor that taking in the size from the user, each user can instantiate and pass in the size too, if you know the size. So this is going to be the size, right, in state. All right, so we have two constructors for the user level to use. Now user, when they don't know how to implement, they just do the push, they pass the element in. This should be E, right? Because user is going to have to do the concrete type when they find it, right? To use. Now when we talk about user, we can actually look at our user in the model right there, right? I'm talking about here. Instead of using array list, I may test just, let's commenting this out, right? This is our old code. We use array list. Now we're going to use our own. We can test with using private static. So array list, or this is no longer array list. It's going to be, if I want to try my bounded stack and put user into the stack, name user list equals to new bounded stack. Something like that. And then when you do, we just test in our method, right? This pretty much just get. But in your method, you have to, this is pretty much just return the list again. You have to do .pop.push instead, right? And no longer array list. I just try to show you this is the user level when they use. They don't have to worry about implementation, right? Now, that's why this come to, you have to use JUnit to test, because you don't want to keep changing your code every time like that for each of the structure for your assignment. Okay, so in your assignment you have stack, queue, order list, index list. You don't want to keep doing that inside, right? Keep changing. Then you require to use the JUnit to test. As we can. So I will show you after we're done creating the stack, the bounded stack, then I'll show you how to use JUnit to test other operations. All right, pop is going to be return E2, right? It's a generic type. same E here. Since I use the auto insert, so it's just put object. So what's push gonna do? We know that this is an array. We just need to keep tracking on index, right? Index. So we already have element, right? At the index is equals to the element. That's how you push. You add something into, right? I happen to name it the same here. Okay, so that's the time that we might want to do this dot elements and give the index. So index is pretty much the size, right? Whenever you do that, now this is capitalized, that's fine. When you do the size, it's going to be returned size. So that means you require to have something to count, right? Private int size and starting with 0, right? Well, it's empty, right? So is it empty? Easy, right? Just say size equal to 0. It's empty. If size equal to 0, it's return true, right? That's how you implement is empty. Is full. So size equals to the constant size, or because user can has its own size, so that's something that we have to actually changing the name a little bit. Caps. Cap. Capacity. Then if the user defines own capacity, then this dot capacity equals to what? The size, right? And we can just say, yeah, it's the same like size or capacity here. Now we have the capacity by default equals to the size, right? Then is full, that means the size of the contents, right? If it's equals to the capacity, right? Then that's full. So we done is full, we done size is empty. Top, let's just return this dot element at the index, which is the size. If you're deciding that whenever you insert at the end just like the top, if you just do flip it bottom up, right? You stack pretty much as whatever at the end of the index, that's the top. And the first index is at the bottom of the stack. The 0 is at the bottom. So top just return that, but not removing. Pop. So we push and we keep increasing the size. After we push, we have to increment the size. We should increment later because we have to push into index 0 first, otherwise it's going to push into index 1, right? The order is important, right? Now pop. When you pop, pretty much just same exact like that, but do the null, right?